Welcome to EDU World Space.
For this problem, we have been given a triple integral. This is an iterated integral. We've already put it in order, dz, dy, dx. And this is related to the picture that's shown in your book. So this problem will probably make a little more sense if you do have your book open to problem 33, so you can see the shape that we're talking about. Now, this is in a certain order. First, we would find the integral with respect to z, then we would integrate for y, and then x. But that's not the only way we could have done this. We could have done a triple integral. I'm going to come back and put in these limits in a minute. I could have done dz, dx, dy. That's the second one. I didn't have to have the z first. I could do dy, dz, dx. I could have done dy, dx, dz. Or I could have put the x first. I could have had dx, dy, dz. Or dx, dz, dy. Any one of those six I could do in the order. What I really need to make sure I do, though, is get the limits of integration correct. So, again, in each of these cases, I am taking the integral of the function. I just didn't copy that piece down, especially because we don't know what the function actually is as far as being able to just write it down there. So that's what we have. So how do I write these limits of integration? How do we find them? Well, the nice thing about the problem is they've told us how these variables relate to each other. If you look at the picture, you can see that y equals the square root of x. Or I could say x equals y squared. So that's one way that x and y relate to each other. I also know that z equals 1 minus y. Or I could say that y equals 1 minus z. So that's another way that I can say that these will relate to each other. Okay. If I wanted to go from x to z, well, x is y squared, y is 1 minus z. So I could say that x is 1 minus z squared. So I can get from one variable to the others. So let's come back to our problem here. First one. Again, we've been given that one, so we don't have to go back and look at that. So what if I did dz, dx, dy? Well, let's look at z first. How does z, let's kind of look here, how does z relate to the other variables? Well, z equals 1 minus y. So I can say that z is going to go from 0 to 1 minus y. That's a later variable down the road, so I can write it like that. Next, I have x. Now I have to put x in terms of y. X is going to go from 0 to y squared. We know that x equals y squared. It's one of the things I put over here in red. I put a little green arrow next to it so you can see it there. Okay, and then I know then that y is going to go from 0 to 1. Okay, now what if I did y first? So that's our next two. I'm going to do dy first. Well, in either case, if you look at that picture, y is going to go from the square root of x to 1 minus, I'm sorry, say that backwards. Square root of x to 1 minus z. That's the limits there. So in either case, whether I'm going dy, dz, dx, or dy, dx, dz, I'm going to go from the square root of x to 1 minus z. Square root of x to 1 minus z. Okay, what if I do z next? Well, how does z relate to x? Well, z is going to go from 0 to x, which is 1 minus the square root of x. If z is 1 minus y, y is the square root of x, z is going to be, and I should have written that down originally, z is 1 minus the square root of x, just based on the equations that they've given us. And then x goes from 0 to 1. Okay, our fourth case, we know we already have those first limits of integration, but now we want to put x in terms of z. Well, x is going to go from 0, and I know that x is 1 minus z squared. That's how those relate to each other. And then z would go from 0 to 1. That's a squared. Okay, now what about dx being our first integration that we do? Well, x is y squared, so I can say that x goes from 0 to y squared in both cases. Okay. Now, what if I do y next? That's our number 5 here. Dx, dy, dz. If y is next, I need to put y in terms of z. So y is going to go from 0 to 1 minus z. And then z goes from 0 to 1. If I do dx, dz, dy, I need to put z now in terms of y. So z is going to go from 0 to 1 minus y. And then y finishes again by going from 0 to 1. So we can change the order that we do this integration in as long as we're careful about our limits. Sometimes some limits are easier to find than others. Sometimes the integration is easier if you do it in one order versus another. So there might be a reason to pick one of these as preferential over another, but they will all end up giving you the same answer at the final step.